Good morning, good afternoon, or good evening, depending on where you are in the world, and welcome to today's DevOps.com webinar, brought to you by TechStrong. My name is Cody J. Brown, and I will be moderating today's session. We have an exciting presentation ahead of us today, but before we begin, I have just a few housekeeping notes. Today's event is being recorded, so if you miss any or all of the discussion, it will be made available for you. You will receive an email after the webinar concludes with a link to access the on-demand. We want to hear from you, so please feel free to send in your questions at any time throughout the program by using the Q&A tab. We will try to address as many of these questions as we can, so please send them in early. We also encourage discussion by using the chat tab. Let us know your thoughts, comments, or concerns, or just say a quick hello. Finally, at the end of today's webinar, we will have a drawing for 4 $25 Amazon gift cards. Stick around to see if you are one of our 4 lucky winners. Well, let's go ahead and kick off our webinar today as we revisit the Enterprise DevOps series. This installment is titled CI/CD for Mainframe, and I'm joined today by Michael Bauer, the DevOps lead and Zowe squad lead at Broadcom. Michael, thank you so much for being here with us today, and the floor is yours.
Thank you, and thanks everyone for joining. I hope to make today's presentation on CI/CD for Mainframe an exciting one. And I wish you all the best of luck in winning the random draw at the end of the presentation. So without further ado, let's get started. So just a brief disclaimer that this presentation is for informational purposes only. And before I get started, I just want to share a little bit about myself. So I started as a software engineer at CA Technologies, now Broadcom, about 6.5 years ago. And when I began my journey in the mainframe space, none of the technologies that I'm going to share with you today were being used in full force. And it's been quite a journey into the development of these technologies and how they enable DevOps for the mainframe. I'm excited to share that with all of you today. When I first started here at CA Technologies, now Broadcom, I was an associate software engineer, and I gained experience working on ZOS applications as well as building modern web interfaces for those applications. I transitioned into a product owner role just about 4 years ago now for what is now known as the Zowe CLI. And now I'm a technical steering committee member for both the Zowe project as well as the COBOL programming course. If you're unfamiliar with these projects, I'll touch a lot on Zowe throughout this presentation. The COBOL programming course is just another project underneath the Open Mainframe project, which is underneath the Linux Foundation, targeted at helping folks learn the language and get started really on the mainframe in general. And I'm also the Zowe command line interface squad lead. And if you haven't seen a mainframe, here's myself standing next to a IBM Z14 mainframe. On the lighter side of things, when I'm not working on DevOps technologies and working on the mainframe, I enjoy hiking with my wife, Shannon, as well as our terrain walker, coonhound, Mira. And I also enjoy going fast on the weekends. Maybe that's why I like DevOps, but if you ever want to talk about race cars or anything with wheels, automotive in general, feel free to hit me up at a conference or talk on Slack. The agenda for today, I want to briefly touch on the critical aspects of mainframe, why it's important to today's society and sort of life as we know it. Also, the challenges that have faced the platform as far as modernization and DevOps enablement. I want to talk about the Zowe project and how that can help us achieve DevOps on the mainframe, and how we can integrate mainframe into our enterprise continuous integration and delivery pipelines. And then it's time for a live demo, which that's the most exciting part of the presentation, I think, and I look forward to providing that. And then we'll finish up with some resources and possible next steps for each of you if you're interested in learning more. So the importance of mainframe. Some key benefits of the mainframe platform are its scalability, its resilience and high availability, its unparalleled security, and its backwards compatibility. This has allowed mission-critical workload to be run on the mainframe for many years. It can handle the transaction workload, and it with reliability. Some interesting facts that I found about the mainframe and why it's so exciting to work on the mainframe every day is that mainframes are used by 71% of the Fortune 500 companies, handle 90% of all credit card transactions. And I think my favorite point is as of 2019, 96 of the world's 100 largest banks, 9 out of 10 of the world's largest insurance companies, and 23 of the 25 largest retailers in the US continue to use mainframe. So what are some of the challenges to modernization on the mainframe and DevOps enablement? Before I dive too much into that, I want to justify the argument for why we need DevOps on the mainframe. Clearly, mainframe is mission critical in today's world, but the other important fact is that it continues to grow. The lack of agile development practices and an established DevOps culture are barriers to enterprises who are trying to move with speed while working with the mainframe. And the theme of agile development is iterative feedback. We try to put things out and get feedback from our customers and then implement new features based on that feedback. And DevOps aims to shorten the software development lifecycle, allowing us to respond effectively to those changes and produce software in shorter iterations. So just to highlight is that there's a lot of development still going on the mainframe, and it's important to modernize and allow those applications to be developed with speed. So some of the challenges that have faced the platform are that enterprise teams developing are too slow. They need more than a month to get software out the door, and a lot of their time is spent building or with overcoming environmental challenges rather than coding, and they're limited by the choice of tools. That's what we saw when I first started on mainframe. In fact, I'd be working mostly in what we see here on the left side of the screen, working on ISPF, TSO interfaces. And I still work with JCL and Rex today, but the way in which I work with them is through modern tooling. And you also had the emergence of Eclipse IDEs, which were adopted, but they were supported by vendor plugins, and sometimes you needed to wait on vendors to produce some software to enable you to basically have the functionality you desired. Now we transition into DevOps innovation and open source. And the open first, open choice approach drives highly visible benefits. CI/CD is the new normal, and DevOps tooling helps developers focus on higher value tasks like design and coding rather than repetitive tasks like compilation and deploying to test environments. And instead of doing manual tests, writing automated tests to save them time on future releases. Now, we're not saying you need to get rid of those tools on the previous screen. A lot of folks are very, very efficient in ISPF or Eclipse, but we are giving you a choice. We're going to give you the ability to leverage all the tools that have enabled DevOps on the distributed side and enable the next generation of developers coming into organizations to use tools that they're familiar with. Perhaps they still have to learn things like JCL and Rex, but they don't have to learn the proprietary interfaces that are generally used just for mainframe, like ISPF. They can develop on the mainframe using the same tools and technologies they're already familiar with. So open source is everywhere, and it's dominating app development. In fact, according to Gartner, 95% of organizations leverage non-trivial open source software assets within their mission-critical IT workloads, whether they know that or not. And that stat is back in 2016. It's likely even higher now. 99% of Fortune 500 companies leverage open source. 68% of IT leaders increased their use of open source last year. And 89% of developers view open source as equal or higher quality than proprietary tools. And as a personal example, all the technologies on the bottom of the screen here, I use on a daily basis, and I'm leveraging them to develop mainframe and enterprise software. So how can Zowe help? Well, Zowe is the enabler for Mainframe to integrate with all of these open source tools. It's the key to opening the mainframe to these tool chains that I mentioned, tools like VS Code, tools like Git, etc., and the modern DevOps practices. It opens mainframe securely to enterprise DevOps. It builds a community around mainframe DevOps, and it makes mainframe an exciting career choice. And this is becoming a mature technology. Zowe was first established back in 2019 from initial contributions from Broadcom, IBM, and Rocket, and now has more than 30,000 commits. And for example, the CLI has over 70,000 installations, so it's heavily used. Now diving in a little bit more to the technical details of the makeup of Zowe, it all starts with mainframe REST APIs. So the mainframe is becoming REST API enabled. That's allowing connectivity from off-platform tools, and the Zowe's role in this ecosystem is to secure that access, monitor that access, make it easier to access all of these REST APIs. First example of this is seen in the API mediation layer. As REST APIs become more available, we need this means to manage them. The API mediation layer fulfills this need. It consists of three components: an API catalog, a discovery service, and an API gateway. The API catalog provides a graphical view of all the REST APIs so that users can know what can be accessed easily. The discovery service allows for REST APIs to be dynamically added to that catalog. And the API gateway, which I'm going to touch on a lot more throughout this presentation, provides a secure single entry point for all API requests. Without the API ML, it's difficult to configure client technology to connect directly to each REST API. And for security administrators, it's problematic in having to open up ports for each one of these REST services. There's no centralized security means for authentication, etc. So all of these challenges are overcome with the API mediation layer, and I'll be showing that in more detail. On top of the API mediation layer, there are a variety of clients. The two clients that are, well, I'd say three clients here that are most critical to DevOps enablement are the Zowe Client SDK, which allows easy scripting to the mainframe platform, the CLI, which provides both interactive and scripting ability to the mainframe platform, as well as lightweight IDEs such as Visual Studio Code, and being able to easily work with the mainframe from those IDEs. Did I mention that the Zowe platform was extensible? Here we see 20 conformant REST APIs that all integrate with the API mediation layer. And now let me talk a little bit more about the importance of the API mediation layer. And keep in mind that this ecosystem of APIs continues to grow, and more organizations are enabling REST APIs on the mainframe. Consider life without the API mediation layer. Here we have Ravi, Michelle, and Tyler. Ravi's a DevOps engineer, Michelle's an application developer, Tyler's a system administrator. They're all working with a variety of Zowe client technologies. Here we see Ravi, he's working in Visual Studio Code, the command line interface, as well as Jenkins. Michelle's working in Visual Studio Code and the command line interface. And Tyler's working in those plus the web desktop, which is another client technology of Zowe. Each one of these personas are accessing services individually on the mainframe. This means they have to configure their client technologies to interact with each one of these services. And this means on the other side, the security administrator has to open up each one of these ports. This is greatly simplified and secured with the API mediation layer. Here we see each persona interacting directly with the mediation layer, and then the mediation layer routing their requests to the appropriate service. This type of layout provides for single sign-on and easy viewing of the available services on the mainframe through the API catalog. This provides a better user experience. It also allows for redundant services. So if you think in the terms of DevOps, where we have pipelines running that are responsible for possibly promoting code changes or deploying software into test environments or even into production environments, you don't want anything disrupting those pipelines. If you have redundant services and one happens to go down, that will not impact those pipelines. It also means that we only have to open up a single port to access each one of these services. And it means that security is standardized, as I'll show more on the following slide. For API mediation layer, all communication is done over TLS, HTTPS, and you log in to the API mediation layer and you obtain a token that's used for further requests. This is very important in organizations that enforce multi-factor authentication. Otherwise, each time you made a request to a service, you'd have to provide that second factor. In this case, you log in once, you receive back a token, and then that token, which you can revoke access at any time, perhaps it has a lifetime of 4 hours or so, allows you to make subsequent requests. And then again, your request would be appropriately routed to each service. And this setup also provides, as I touched on a little bit earlier, provides a sessionless experience, meaning that if I perform one request and then the service goes down, as there's a redundant service in the background, I won't notice that from an API consumer point of view. Now let's transition to the Zowe CLI, the command line interface that leverages these REST APIs through the API mediation layer. We see that there are 26 conformant Zowe CLI plugins offering access to many different services on the mainframe. Services like source control, which is typically CA Endeavor on the mainframe, or services like debugging, file manipulation utilities, access to data sets and files on the mainframe, etc. And the CLI is viewed, I view it as a bridge tool. So the command line interface typically runs on the distributed platform. And because it runs on a distributed platform, it allows you to integrate with all the other tools typically used in distributed development, IDEs like Visual Studio Code, task runners like NPM scripts, as I'll show in my demo later, or Gulp, testing frameworks like Mocha and Jest, code analysis tools like SonarQube, and the list goes on. And even the number of packages that are available to aid in your development are very significant, what's available. There's more than 1 million packages available on public NPM, which is Node's public registry, and over 250,000 available on pypy.org, which is Python's registry. So there's a lot of packages that are available out there that help accelerate your software development. Now moving on to integrating mainframe into enterprise CI/CD. So here we see the Zowe CLI bridge the gap between modern tools and the mainframe. And up till now, I've been talking a lot about all the open source tools that this enables. As shown here on the left, languages like Python, CI/CD tools like Jenkins, things like that. But as I mentioned earlier, we've seen an emergence of REST APIs on the mainframe. And these APIs enable us remote access to various services. And a tool like Zowe CLI allows for real-time exploration of services and enables automation to be rapidly developed. In this scenario, we see on the mainframe backend services like ZOSMF, which allows us to perform basic operations on ZOS, including interacting with the file system, running workloads, etc. CA Endeavor is a common source control management system. FileMaster Plus provides powerful tooling for manipulating ZOS datasets. Ops MVS, event management and automation, is a leader in mainframe automation, responding automatically to system events, detecting issues before impacting users. And for example, with that, you can remotely enable roles for the system to detect, and so on. So there's a lot of different services running on the mainframe, and we can interact with them remotely. And in the demonstration, I believe we will be interacting with ZOSMF, KICS, which for those unfamiliar, stands for Customer Information Control System. It's an online transaction management solution. We'll also be interacting with DB2, which is a relational database. We'll be leveraging that FileMaster Plus I mentioned to copy files around on the mainframe. And we'll be leveraging Endeavor. That's where the source code for the example will live, and so on. Now, if you're looking for a more integrated experience with a particular programming language, you can also look to our suite of SDKs. So in Zowe, there's a variety of SDKs that are currently out there. SDKs for Node, that's the most well built out SDK library. But there's also ones out there for Python, Java, Swift, and so on. So very similar to interacting with any one of the cloud platforms. For example, if you look at AWS tools, they have a CLI as well as SDKs for interacting with their services, and mainframe is very similar. So if you do consider moving to that more integrated experience with a particular programming language such as Node, you would also benefit from our Tests for Z solution. Tests for Z provides a Node SDK with use cases, with functionality that's targeted towards testing use cases. And it's also available in our Broadcom's Brightside solution, which also provides support for the Zowe components. Now let's take a little bit of a closer look at Tests for Z. So I think there's I view two key benefits of Tests for Z. One is on the client side with this SDK. It makes things like comparing data sets for what you expect to be in them, or searching for something to be within the data very, very easy to build out. And I'll show that in my demonstration. But you can also include that then into tools like CI/CD, just like you would tools like Jenkins for CI/CD, just like you would in the distributed world. This eliminates things like manual testing, context switching, and delivers higher quality code. Now, the other piece of Tests for Z is on the mainframe side. There's a service that provides these endpoints. These endpoints are very valuable for test automation. Things like comparing data sets, searching on a data set for a particular item, creating a snapshot of a data set so that you can, for example, take a snapshot of the data, run a program, a batch utility, evaluate the results of that utility, and then restore it to its previous state. And we'll be showing that in a little bit more detail in the demonstration. Here's one example, is that you can have an example. Here's an example Jest test script where we pretty much do what I mentioned, and we'll cover this in more detail in the demonstration. But backing up a data set, running a batch utility, ensuring the outputs matches the expected results, and then rolling back to the initial state. And all of this is accomplished here, shown in about 17 lines of code. And once you put in this one-time investment, your next iterations will be much faster, right? That's the driver behind automated integration testing. For even more details on Tests for Z, I would encourage you to check out the Enterprise DevOps Series Mainframe Test Automation presentation delivered by my colleague, Petr Vacula. And that was a DevOps.com webinar recorded on September 28th. So let's jump in to a demo. Okay, so this is my favorite part here is we're going through the bright door. These are some of the technologies that will be leveraged in this demo. So we'll use a lot of Code for Z, which is a suite of VS Code extensions, as well as components of Zowe and Test for Z, which I just mentioned, as well as these other open source tooling that a lot of folks on the call are likely familiar with. Tools like NPM scripts, Jenkins, Jest, Visual Studio Code, Git, SonarQube, and Node. All right, so let me jump into a demo here. Okay, so here I'm just in my Visual Studio Code environment. And the first thing I want to show is just how to get started with the CLI. If you already have Node installed and NPM installed, you can simply issue npm install at Zowe/CLI and then the version level you want to install at. So for example, you could install Zowe v1 LTS. That's the supported version today, or you can install the technical preview, which is next. I happen to already have the next version installed on my machine. And then you can just get started running Zowe commands. Even before you have anything set up on the mainframe, you can start exploring the help. So one way to explore the help is just drill down by each group. So I typed in Zowe, gives me my top level. Then I could dig in and do like Zowe ZOS files. But what I typically recommend folks do to get started is issue Zowe --HW or --help-web. And this will build the help and launch it in your browser. And it's already based on the plugins you have installed. So I mentioned there were 26 conformant CLI plugins. Here I only have a few of those plugins installed. And it provides the relevant help for each one of those. And then I can just start clicking in depending on what I'm interested in. So let's say maybe the first thing we're interested in is just listing data sets on the mainframe. So I see here that there's ZOS files, manage ZOS data sets. And then maybe there's some actions here. So copy, create, delete, list. I'm going to choose list. And for example, I can list data sets or all members of a PDS. And here I'll see examples on how to get up and running. So then if I transition back here, now I would need configurations set up, which I can show momentarily. But I can do Zowe files, list, dataset, for example, here. Okay. And this lists my data sets on the mainframe. And maybe I'm interested in listing all members of a data set, and maybe marbles.jcl in the list above catches my eye. So now I've listed all members, and maybe I'm interested in the marbind JCL. And maybe I want to verify before I submit that job that it's going to run correctly. So I can actually take advantage of the JCL check service I have on the mainframe to make sure that, one, the JCL here is syntactically correct, and two, that it satisfies all of the conditions necessary for runtime. So it'll evaluate whether I have access to everything I need for that JCL to run successfully. Marbles.jcl. Marbind. Okay, and we can see here we're in good shape. So I'm just showing that I can interact with the mainframe from a distributed environment. And that's what's really powerful about Zowe, because now that I can do that, I can integrate mainframe with all of these other distributed technologies. Like here I'm in VS Code, but since I'm doing this with a command line interface and showing quick exploration, the next step with the command line interface is to abstract those simple commands, those simple building blocks, into more complex scripts that achieve more value. If I was really just interactively working with the mainframe with no intent to really automate these things, you could also leverage Zowe Explore, which is generally what I would use for interactive usage. So achieving the same thing in Zowe Explore, these share configuration information, and I can launch, I can show the configuration information here in a second. I'll show that when I get to my project. But I can basically achieve the same thing. So I can search for data sets on the mainframe. And here I can look for marbles.jcl. And I can pull up the marbine file. And I have syntax highlighting here provided by the JCL language support extension. And in fact, I have the Code for Z extension pack installed, which provides a lot of things like syntax highlighting, visualization of COBOL programs, which I'll show in a bit, and just makes overall development, a lot easier. For example, for JCL, I have code snippets. So for example, if I wanted to maybe allocate a data set, here's IAFBR14, and I just need to fill in the parameters. It makes it easy to quickly build and validate JCL before I go and submit it. And things like JCL check can provide a huge time savings on automated pipelines, because you can verify that JCL up front before you spend the resources trying to exercise it. Okay. So now I'm going to transition a little bit into what I would do as a developer working on a mainframe application. And let's consider a mainframe application that's a COBOL CI/CS application. And what I want to do is I want to build the application, deploy it to some test environment, and then run some automated tests. So how would I go about doing that? Let's go over to the file explorer here and DevOps Zowe demo. So now that I've run those commands interactively, you could start abstracting them into scripts. And what I see a lot of folks doing to get started, because they might not remember the long syntax of these commands, is you can go ahead and put a Zowe command right in here. Right in, this happens to be npm scripts. It's a task runner in Node. And for example, if I wanted to leverage this, I could do npm run JCL check. It's going to run the same command I ran above. If you're a fan of UI over CLI, all of this integrates nicely with my IDE. So I can run JCL check here. And also these displays I wanted to mention are completely configurable. So if I wanted, all of this over in my file explorer, for example, you can move these things around. So here I move this around. Just showing that you can fully customize the environment to meet your personal preferences. Now, I've ran these commands, but maybe I want to do something a little bit more complex. So you'll see in package.json, there's also ones that are calling scripts. So I have my more complex scripts that aren't just single commands organized in this scripts folder. Now, if I look at build, it calls build COBOL and build the LNK element. And you'll see under the covers, this is doing nothing more than issuing a Zowe CLI command. And it also archives all the output. So if I want to see the results of a previous command I ran, I can see that. And this works well in Jenkins pipeline, where you can have in context output. So if a job fails, for example, or even if a job passes and you want to look back on a pipeline, that data will be available for you in context. So without further ado, I can run these commands interactively. But before I do that, I want to show, once you have the npm scripts, the steps to put this in a Jenkins pipeline are fairly small. So here, just as I was running those from the command line, you can run those same commands from your Jenkins file. And what this shows up as in Jenkins is this is the pipeline run. So we can see actually on my most recent pipeline run, the application failed on this test. And I can get a nice graphical view here that shows it failed on should create a single marble with cost 1. The extraneous argument, so the cost argument here was ignored. So we're going to make a change to this COBOL application to make our tests pass. So let's return to Visual Studio Code. And if I was, there's a few ways to do this. For a simple demo, I'm just going to pull the element out of Endeavor using the Endeavor CLI plugin. You could also leverage our Bridge Forget solution, Endeavor Bridge Forget. This allows you to interact with Endeavor just like you're interacting with any enterprise Git server project, whether you're using Bitbucket, Azure DevOps, or enterprise GitHub. But for this simple example, I'm going to just run a Zowe Endeavor retrieve element. Or here, first I'll do Zowe Endeavor list elements so you can see the elements that are in the sandbox. Okay, and I'm particularly interested in this marble 01 element. So if I want to pull that, I can run I think I have it here. Yep. Zowe Endeavor retrieve element. It's the type COBOL, stage number is 1, and I'm going to land it in a marble01.cbl file. Let me run that. So then we see that it pulled it into my project. I'm just going to make a quick edit. In here, again, Code for Z is providing this syntax highlighting through the COBOL language support VS Code plugin. I also have COBOL control flow set up, and it gives me visualization of this, the structure of this COBOL program. So actually, the change I want to make, happen to know it's in the parse kicks input function section here. So I'm going to uncomment this line. And it's not really important what the change is. What's important is how I can automate the build, deploy to test, and test of this application. So I made this change, and I've saved it off. So now I'm just going to do a Zowe Endeavor update element command. I don't need a stage number for this. And looks good. Update element. Okay, so I made my change. Now, as developers should do, I'm going to build, deploy to test, and test this environment before it goes through the Jenkins pipeline. So let me do npm run build. And again, you could use the GUI here, but I'm a CLI fan, so I'm going to use the CLI. So right now it's building the COBOL element on the mainframe, and then it's going to move on and build the LNK element. Next, we will do npm run deploy. This is going to copy some libraries around. So it's going to copy a load lib, and it's going to copy a dbrm lib into a test CICS environment. And then we're going to run a bind and grant. And then finally, so this is actually submitting JCL, making sure that returns with a particular return code. And then when that's complete, we're going to refresh the application in Kix. This is equivalent to a CI/CS new copy. And then finally, we can do npm run test. And we should see that this will now pass the first test instead of failing. See? Okay. So now it's completed this first test successfully. So we should be good with the code change we made. Now, typically, what I would recommend doing after this is opening a pull request into master and then having it being code reviewed, and then it would, upon merge, get synced up with Endeavor. Since I didn't use bridge forget in this case, I already made the change and pushed it to Endeavor. We're just going to manually kick off the pipeline. Let me go back and manually kick off the pipeline. Okay. And while that's running, we can look at the last run of the pipeline and what it did. So for local setup, it's just logging sort of the environment, so the version of Node I'm running, and this is all running inside of a Docker container. The plugins that I need for the pipeline, so you can see I'm using Endeavor, FileMaster Plus, JCL check, Kix, and DB2, because the test is effectively running a Kix transaction and then verifying the backend data was updated in the DB2 table. We can see there's a section here for code scanning. Currently, just showing the equivalent, is you could pull the COBOL code locally and run it in a SonarQube instance or any code scanning solution you implement in your enterprise. But you can also do on mainframe checks like JCL check to ensure that this mar bind JCL that I need to run later on during the deploy step is valid. So I don't waste time building the application only to fail on deploy. And then for the rest of these, I'm just doing the same thing that I did interactively, where it's doing npm run build, deploy, test. And then, as I mentioned, in a particular pipeline run, all the results are archived. So if I wanted to go back and look at, for example, the JCL that was submitted here, I can see that. Or if I wanted to see the command that was run and its output, I can look at that. So this is the output from the generate command. Okay. While we're still waiting for this to run, I'm going to move on for the sake of time. I'll come back to this, to the test for Z example. So again, everything I showed here, you just use CLI commands to perform the build, deploy, test. If you wanted a little tighter integration with your particular language, in this case, TypeScript or JavaScript, you can check out test for Z. So the one-stop shop for examples I recommend is Zowe CLI Broadcom product scripts. If you go into here, you'll see the symlink here to test for Z repo. And this repository provides samples for how to get started. And this is what I'm going to show in this next demonstration. So if I go to VS Code, I have another project, test for Z pipeline. And the key is if you're leveraging this to get started with your automated testing, you can look in source, test, and then you'll see different test examples. So let me just hide this real quick. Okay. You can see compare, for example, which is the one I'm going to show. And you can kind of easily follow the documentation in this sample to see how it works. So first off, it's going to take a snapshot of the main data set and move it to a copy data set. Then it's going to run a batch application that modifies the main data set. And it's going to compare the main data set with the copy data set to identify any changes. And if you were just using the regular Zowe Node SDK, there would be quite a bit more logic included here, but the test for Z service abstracts a lot of this away for you. So you can just simply leverage that service to take a snapshot, leverage that service to submit the job, leverage that service to then compare, and then use assertions on the result of this. So everything is loaded in the compare result. Then you're checking, in this case, for this particular application, that the old records processed, new records processed are both 75. You've changed 24 lines, you matched 51, that sums to 75, so you've deleted 0 lines. And you can run these examples and try them out in that repository. But I wanted to show how you can then take that and include it in a Jenkins pipeline. So the first step I take to do that is create a npm script. So here I have this compare test, and I can run that interactively. Npm run compare test. Let me see. Oh, I need to change my project here. 1 second. So change into test for Z pipeline and run npm run compare test. And then this will while this is running, we're going to move into the Jenkins file. And again, I'm just going to do a very similar thing in the Jenkins pipeline run. So you see npm run compare test here. Now let's return to Jenkins. And we have, okay, so this one completed now. If we look in the logs, see it completed successfully. This was the one we were waiting on. But moving to the other pipeline, test for Z, master. For sake of time here, I'm not going to rerun the pipeline, but you can see this. Run here within the pipeline. So we see it passed as well. So we were able to leverage the test for Z solution in a CI/CD pipeline. And I think I saw a question in the chat which was asking how does the Zowe CLI, how does it know what services to interact with on the mainframe? Well, this all is contained within this config JSON. And if you're familiar with Zowe CLI, this is a relatively new improvement to how the CLI can be configured. So in the previous release, we had profiles for each service. Now it's a single configuration file. And the nice thing about this single configuration file is it can be easily shared amongst teams within an organization or projects. So for example, the scope of this particular configuration is just this DevOps Zowe demo project. And this is what Jenkins is leveraging as well. You can choose which properties to store securely. So for this demo, stored host, username, and password securely here. And by securely, I mean they're stored in your operating system secure credential vault. So if you're on Windows, that's Windows Secure Credential Vault. If you're on Mac OS, that's a Systems Keychain. If you're on a Linux distribution, I believe it's libsecret here. And I could just share this with anybody in the organization, and they can basically get started running commands. And you can either scope this globally so that you can run commands anywhere on your machine, or you can scope it as part of a project. So actually, for example, this test for Z pipeline, it's actually running against a completely different LPAR than this DevOps Zowe demo project. It just has a separate Zowe config JSON. So that was a good question. So I hope this has been somewhat inspiring. Maybe you can leverage additional distributed tools of your choice. But basically, the CLI here is the enabler. So it allows me to work with the mainframe services from a distributed environment, like Visual Studio Code, like Jenkins, leverage tools like NPM scripts, leverage tools like Jest, like Mocha. You can run this technology in containers. Actually, the pipelines you saw, they were running in containers with Zowe CLI and the plugins installed. And it makes for a very similar experience as if I was developing on a distributed application, really. So with that, I'm going to return to the presentation and give you some resources to follow up with after this demonstration. So here is a list of key Zowe CLI use cases. Now, I touched on some of these, not all of these within this presentation, but these should provide much more details about particular use cases. So just head on over to medium.com/Zowe or medium.com/modern mainframe for more details. Some ones I'll just briefly highlight here are how to write cleaner and safer code, ZOS code with Zowe CLI and SonarQube. If you have an enterprise instance of SonarQube, you can scan your COBOL source code. You can automate CA Endeavor package shipments with Zowe CLI. So if you're looking to improve your Endeavor packaging process from a remote pipeline, I encourage you to check that out. Here's a blog on how the CA SysView team leveraged their own plugin in their CI/CD pipelines. You can do things like this to detect on performance changes and things like that. I mentioned a little bit on how to use Zowe Node SDK. Mostly we were seeing the Test for Z service, the Test for Z SDK. If you're interested in general on this, check out Dan's blog on how to use Zowe Node client SDK. Also touched on JCL check and how I was using that to verify my JCL was going to work before I ran the pipeline. Gene has a nice blog summarizing that. And finally, I have a blog on continuous integration for a mainframe app and hope to publish an update to that based on the next release of Zowe in the near future. So please be sure to check out those use cases. And thank you very much for attending today's webinar. I hope that was exciting. It's exciting for me. Live demos always are. If you have any questions or any comments or just want to reach out in general, please do. My email address, michael.bauer2, don't forget the 2 @broadcom.com. And now I'm going to check to see if we have any questions.
Hey, David. So we do have a couple questions. The first one that came in is, how did the CLI know how to connect to the mainframe, and how are the credentials managed on the client?
Okay, so let me go back to my screen. So again, it knew how to access the mainframe because, for example, the port of the service that I was accessing was here, and the host, user, and password that I was using to connect was stored securely here. Now, in the Jenkins pipeline, it's slightly different because I actually don't. Let me go to the other Jenkins file here real quick. Jenkins file. I actually use Jenkins credential management. So I have variables stored in Jenkins, and here's one example of how you can access those credentials. So this means there's a value stored in EOS host on the Jenkins instance, and I put it in this Zowe opt host variable. That's true for the whole execution time of the pipeline. And then I have this with credentials block to basically get the username and password out of EOS creds in the credential vault, the Jenkins credential vault. And then I leverage it just for this very, very minimal amount of time. And yeah, I think that's pretty much covers it. These are stored again just in, if you go to Jenkins here, and I go to this pipeline, master, up one level, whoops, credentials. You can store credentials inside of Jenkins just like this. So I have these values stored. I think that ought to cover that question. Is there another question in the chat?
Yes. Our next one is, do you have any materials that summarize the mainframe capabilities within VS Code today?
Okay, yeah, we do. For VS Code, I'd actually encourage you to check out this Mainframe Developer Cockpit. And actually, if you just search, I think, in Google Developer Cockpit, it'll come up as your first link. And this summarizes even more than what I showed today. So I just showed a few different pieces in here. For example, I showed the JCL language support extension, and I showed COBOL control flow. But you can also view VSAM datasets using the dataset viewer. You can also debug mainframe applications, debug both Kix and batch programs using debugger for mainframe. I touched on Zowe Explore. There's also an Explorer for Endeavor. So I accessed elements in Endeavor using the CLI, but you could also do that using this VS Code extension. And there's more as well, highlighting these DB2 commands, such as Endeavor commands, DB2 commands, and mat commands as well. Are there any other questions?
Yes, we do have one final question, and it is, how would you recommend I get started with Zowe?
Okay, for getting started with Zowe, I would recommend just going to zowe.org, and you can review the site depending on whether you want to just learn about it, use it, extend it. But if you go to download, that'll contain all your software assets to get started. So you could download the CLI from here. If you read the installation docs, it also tells you that you can install from the online registry. If you're familiar with public NPM, you can just view the packages right on the registry here and install them from here. And finally, if you're just interested in sort of the overview of Zowe, you can find that all in the documentation as well. So that's docs.zowe.org. It's also linked from that zowe.org main page that I showed earlier. All right, I think that's about all the time we have. So I guess I'll turn it over to you to just wrap up.
Yes, and thank you so much, Mike. I really appreciate you taking the time to put together this presentation and run through that demo. Certainly learned quite a bit.
Awesome. Thanks for having me. Thanks everybody for sticking around. Fingers crossed for the drawing for each of you.
So just a quick reminder to everyone that today's session was recorded. If you missed any or all of the presentation, the replay will be made available. Following the webinar, you will receive an email with a link to access the recording on demand. You can also find it on the DevOps website. Just visit devops.com/webinars. Look in the on-demand section and you'll find it waiting for you. So now on to our 4 winners of a $25 Amazon gift card drawing. Our first winner is Don A. So congratulations, Don. Our second winner is Julie H. Our third winner is Joseph D. Congratulations, Joseph. And our final winner is Zoran R. So congratulations, Zoran, and to the other 3 of you. Mike, again, thank you so much for putting everything together. And I would also like to thank our audience for being with us for the entirety of today's presentation. This is Cody J. Brown signing off. Have a great day, everybody.